Morning everyone. Today we are going to go through the past paper for topic 10 gases. We're doing another SPE past paper question, and this is provided and compiled by SBC Brunei. So thank you to all the teachers who have actually compiled these questions for us to do. Okay, don't forget to write down your name, your class, and the date. So let's get into the corrections now. Question number 1. Air consists of high percentage of nitrogen. This is true. The figure below shows the composition of air. What are gases X and Y? So gas X right here is 79%, and we know that should be nitrogen. And we have gas Y, that's 20%. And that should be oxygen. Therefore, our answer is D. The figure below shows the composition of air. What is the percentage of the composition of gases M and N? So here, N is the largest one. We know this one should be nitrogen, and that is 78%. And gas N, that's gas N, and gas M right here refers to, I think that's the 1%. I think that's 0.03% actually. Noble gases is 1%. So this would be carbon dioxide. So the answer is D as well. Now we're moving on to properties of gases. Question number 1. Water vapor turns dry cobalt chloride paper from pink to blue. This is false. So remember we did an experiment on this. So what we did was we had a blow dryer. And then we actually blow dried like a pink. Do I have pink color here? Yeah, I do. So a pink color cobalt chloride paper, and then when we blow dry that pink, it actually turned to blue. And what happened here was because the cobalt chloride paper that we had was pink because we're in Brunei, and Brunei is a very humid country, and humid means it actually comes from the word humidity, and humidity refers to the percentage of water vapor in the air. Since Brunei is very humid, that means that there's a lot of water vapor in the air. We just can't see it. So the water vapor, if we actually switch off the blow dryer, it's going to become pink again because there's just so much water vapor in the air. But cobalt chloride, if it's dry, it should actually become blue. So what water vapor does is that it's going to turn blue to pink. So this statement right here is false. Okay, complete the following passage by using the helping words provided. You may use the words once, more than once, or none at all. That means that you can use these words one time, you can repeatedly use it, or you don't need to use it at all. So here, air is a mixture of gases. The constituents in the air are 78% of nitrogen, 21% of oxygen, and 0.03% of carbon dioxide. something percent is noble gases and water vapor, so that's 1% noble gases. Water vapor, we don't have a percentage of this that is an average all over the world, because water vapor varies depending on the location. For example, if you're in a desert versus if you're in this, like next to the sea, the place where there's more water would have more percentage of water vapor, hence humidity will be high. So the proportion of water vapor in the air varies from place to place. Noble gases are unreactive. It means that it doesn't react very well with anything around them. They react very slowly or none at all. Another unreactive gas in the air is actually nitrogen. So we're using this one. We have used mixture. We have used 1%. The presence of oxygen will rekindle. Rekindle means to relight. So oxygen, the test for oxygen is actually glowing splint. The presence of carbon dioxide can be tested using lime water. Lime water forms a white precipitate. The pie chart in figure below shows the percentages of 4 gases in the atmosphere. So now we need to talk about, I think, which gas refers to which gas. So gas P right here is 1%, and we know that this is, so the 1% is noble gases. And the variable here refers to water vapor. 0.03% refers to carbon dioxide. And 21% refers to oxygen. So what's P? P should be noble gases or water vapor. Because there's 2 types, either noble gases or water vapor here. Gas Q is carbon dioxide. And gas R is oxygen. So gas P could either be noble gases or water vapor, but we don't have a test for noble gases, but we do have a test for water vapor. And water vapor, the test is to turn dry blue cobalt chloride paper to pink, blue cobalt chloride paper to pink. Carbon dioxide, clear lime water turns white precipitate, and oxygen relights a glowing splint. So the answer here is C. Oopsie, my pen has erased that. Okay. Carol carried out 3 tests shown in the figure below to determine the identity of gas Q. What is gas Q? So let's see. Test number 1, glowing splint. And they put gas Q in here. Glowing splint is to test for oxygen. And you have lime water here that tests for carbon dioxide. And lighted splint is a test for hydrogen. So in terms of the glowing splint, it is relighted. That means oxygen is present, but the lime water stays colorless and it doesn't turn white precipitate. That means that carbon dioxide is not present. There's also no pop sound. That means no hydrogen is present, and we are left with oxygen. So gas Q is oxygen. 3 tests were carried out on a colorless gas, and the results are shown in the figure below. From the observation, it can be concluded that this gas is a question mark. So test glowing splint is a test for oxygen. Lime water is a test for carbon dioxide. And cobalt chloride paper is a test for water vapor. Oxygen, the glow is extinguished, goes out, so that's a no. No oxygen gas is present. Lime water does not turn lime water into white precipitate. That means carbon dioxide is not present. And cobalt chloride paper turns from blue to pink. That means yes, there is water vapor. Therefore, the gas present is water vapor. The cobalt chloride paper shown in the figure below is used to test for the presence of water vapor. Which color change best describes the presence of water vapor? Now this should be from blue to pink, and that's A. Nina carried out an investigation on 3 different gases labeled X, Y, and Z. She performed tests 1, 2, 3, and 4, and then recorded the observation. Test with burning splint, this is for hydrogen gas. Test with cobalt chloride paper is for water vapor. Test with lime water should be for carbon dioxide. Test with lighted splint, actually it should be glowing splint. So glowing splint, this is a test for oxygen. The gas, there's no pop sound, so gas X doesn't have hydrogen. Gas Y, it says pop sound is heard. So that means that there is hydrogen gas. No reaction, that means that gas Y doesn't contain hydrogen gas. Gas C also doesn't contain hydrogen gas. In terms of the cobalt chloride paper, gas X, no color change, so it doesn't contain water vapor. But gas Y turns pink, that means there is water vapor. No color change, no water vapor. Lime water, no reaction, no carbon dioxide here, no carbon dioxide here, but there is white precipitate, that means there is carbon dioxide in gas C. No reaction for test with glowing splint, therefore no oxygen. So gas X is hydrogen. Gas Y is water vapor. And gas Z is carbon dioxide. The answer is C. Which one of the following is the identification test for carbon dioxide? Carbon dioxide should be to do with the lime water, so the answer is A. Which of the following noble gases is commonly used in colorful advertisement? That should be neon. The figure below shows a gas jar containing gas Y. Y is a noble gas. Which statement about Y is correct? 78%, that's nitrogen. Unreactive, it is. Y relights the glowing splint. Nope, that's for oxygen. And supports combustion is also oxygen. So the answer here is B. The figure below shows a weather balloon that is filled up with helium gas. Which one of the following properties help to explain the use of helium in weather balloons? So if you are not very familiar with weather balloons, what they are actually, so they have balloons being attached to this thing called a payload module. So over here you have some sensors, and they will actually detect the changes in weather. There's also a parachute here, because actually when the balloon gets up into the atmosphere, and then it's going to actually burst, so you need a parachute so that this can safely land. And what the people do is that they're going to take this and actually look at the sensors and take a look at the readings about the weather. Okay, so helium gas is colorless and odorless, yes, but that doesn't help in being a weather balloon. A lot of other gases are all colorless and odorless. Helium gas is the second lightest gas. Maybe this could be helpful so that it can float up high. Insoluble in water. There is no water here, so it's not very helpful. It's highly flammable. It's not highly flammable. So the answer here is B. Which of the following gives us two uses of nitrogen? Nitrogen has nitrates, and actually the answer for this is to preserve food and making fertilizers. Margarine, I think hydrogen gas, you can make margarine with it. Party balloons, helium, and advertising signs are usually neon. Preserving food and as dry ice, usually dry ice is carbon dioxide. Okay. Helium gas is used in party balloons as shown below. So draw what happens after one day. So what happens is that it's going to either become smaller, or you can draw it like a little bit deflated. What has happened to the helium gas inside the balloon after one day? State a reason why it is suitable. So being light, it can float high. Last part, which is 10.3, hydrogen. When acid is added to metal, so you have acid plus metal, like magnesium, oxygen is produced. Because acid plus metal, you get a metal, salt, plus a gas, which is actually hydrogen. So it's not oxygen. This statement is false. The figure below shows the preparation of hydrogen gas in the lab. Complete the following passage by using the helping words provided. Hydrogen gas is prepared by the reaction of metals and acids. Examples of metals that can be used to prepare hydrogen gas are, so the only one we have here that is metal is zinc. Magnesium and iron. The presence of hydrogen gas is tested by using a glowing splint. Oh, sorry, burning splint. I'm so sorry. Glowing is for oxygen. So not this one. Burning. Where are you, burning? So there's no burning here. So we're using lighted. A pop sound shows that hydrogen is present. On carrying out this test, droplets of water are formed. Hydrogen gas is used as a fuel, weather balloon, and a manufacture of margarine. Hydrogen gas was collected in a test tube below. Burning splint was put inside the test tube, and then droplets of liquid B were formed. Liquid B is H2O. What happens when you actually combust the hydrogen is that the hydrogen gas will react with oxygen. Not like that, that's H2O2. So over here you have hydrogen gas, right? And then you have heat, and it's going to react with the oxygen gas. And what's going to happen is that it's going to form H2O. So that's why you have the pop sound. It's actually an explosion. A mini explosion. Which observation correctly describes these tests? So hydrogen should form a pop sound, and cobalt chloride paper turn from blue to pink. That's A. Most metals react with dilute acids. The figure below shows the preparation of hydrogen gas using the reaction of metal, magnesium with an acid, dilute hydrochloric acid. Complete the word equation of magnesium with dilute hydrochloric acid. So you have your metal plus acid, so you get a metal salt plus hydrogen. So you use the metal, and the salt comes from the acid name, so here chloric, so chloride. Another suitable metal that could be used to prepare hydrogen gas, you can use zinc, you can use was it magnesium? Oh, yeah, iron was one of it, and there's actually other ones. Let's go to gases. I think it's part 2. You can use calcium as well. Sodium, calcium, magnesium, and zinc. But it asks for just one, so you can pick any of these. Describe a test to show the presence of hydrogen gas. So use a burning splint. Hydrogen gas reacts with oxygen gas to form water. Explain why hydrogen gas is an element. So you can see hydrogen here, right? So there's only one type of element there. But for H2O, water, you can see that there's hydrogen and oxygen. So this is not an element, this is a compound. Both of these are molecules, but this is a compound and this is an element. But they're both molecules, means that they're made up of more than one atom joined together. Okay, so that's it for your corrections. Hope you guys make your corrections and hope that this clears everything up. Please text me if you have any questions, and have a good day.